Hi everyone, this is Dr. J. Revathy, Professor of Civil Engineering. We will see on the course Earthquake Engineering. This lecture covers the following topics: natural disaster, earthquake, seismic waves and the types of earthquake, seismogram and how to locate the epicenter, and how to measure the size of an earthquake. What is meant by natural disaster? Natural disasters are those adverse events which results from the natural process of an earth. Examples are earthquake, flood, cyclone, landslides, volcanic eruption and tornado, etc. So you can see from this picture, the picture shows the recent statistics of a natural disaster worldwide by economic damage. And this picture shows the statistics for the loss of life from significant natural disasters. From the statistics, you could see that 55% are due to earthquake. What is meant by earthquake? It is a sudden vibrations of the earth's surface caused by waves from a source of disturbance inside the earth mass. It is usually associated with faulting or breaking of rocks. What is meant by tectonic plates? It is a sliding of earth's mass takes place in pieces called tectonic plates. So there are major 7 tectonic plates. Number 1, North American plate, Pacific plate, African plate, South American plate, Eurasian plate, Australian plate, Antarctica plate. So when you have the movement continuously and pushing each other, what is meant by fault? So these movements cause the rock to deform so that they fracture, and these fractures are called as faults. When the rock fractures, its sudden movement causes an earthquake as shock waves spread away from it. We have various types of faults. Number 1 is a normal fault. It is a dip-slip fault. The fractures are formed as inclined manner. The hanging wall block moves down with respect to the footwall block. It occurs when the crust is being pulled apart. The number 2 fault is called as the reverse or thrust fault. It is a dip-slip fault where here also you can see the inclined fracture. The hanging wall moves up and over the footwall block. It occurs when the crust is being compressed. The third type of fault is called as the lateral strike slip fault. They are occurring as a vertical fracture. The block moves horizontally. Suppose if an observer looking across the fault, it moves to the right, then slip style is termed as right lateral. If the block moves to the left, that motion is called as the left lateral slip fault. It is based upon a theory called elastic rebound theory. Over a long period of time, due to various slow tectonic activities, strains are accumulated at the fault, which is shown in the figure 1. Large strain reaches its limiting value at some point of time. So there may be a heavier slip due to crushing of rock and masses. Thus the strain energy is released, which is as shown in figure 2. Propagation of these elastic stress waves cause the vibratory motion associated with an earthquakes. Strained layers of rock masses bounce to its unstrained condition, which is shown in figure 3. The next is on seismic waves. What is meant by seismic waves? Large strain energy released during earthquake propagates in all directions within earth as elastic medium. These waves are called as seismic waves. It transmits the energy from one point to the other and finally it carried to the earth's surface. It is classified as body waves and surface waves. Body waves can travel through the interior of the earth before the surface waves emitted by an earthquake. It has a characteristics of higher frequency than the surface waves. The body waves can be classified as P waves and S waves. P waves are called as primary waves. It is the fastest kind of seismic wave. It arrives the seismic station first and it can able to move through solid rock and fluids. It has a characteristic to push and pull the rock as it moves. It has a higher velocity of 6 km per second. The second wave is called as the secondary waves or S waves. The S waves are slower than the P waves. It moves through solid rock at a rate of 3.6 km per second in the crust. S waves move rock particles up and down or side to side perpendicular to the direction of the wave. The next wave is called as the surface waves. It is classified as love waves. The first kind of surface wave is called as a love wave. It is the fastest surface wave and moves the ground from side to side. Love waves produce entirely an horizontal motion. The second classification of the surface wave is the Rayleigh waves. It is named after John William Strutt and Lord Rayleigh. Rayleigh waves rolls along the ground. It rolls, it moves the ground up and down and side to side in the same direction and the wave is moving. Most of the shaking felt from an earthquake is due to the Rayleigh wave, which can be much larger than the other waves. The next is on the seismogram. An instrument that detects and measures the vibrations of Earth's surface is called as seismograph. The record made by seismograph is called as the seismogram. The picture shows the seismogram. You could be able to see that the first noise will have a background noise. The earthquake happens at 0 time and we will have a background noise. The first wave reaches the seismic station is the P wave. Then we have the S wave, which arrives at 4 minutes later than the P wave. Surface waves, which arrives later than the P and S waves. The interval between S and P could be able to tell by the seismologist how far away the earthquake was. So far we have seen on the seismic waves and its types and the seismogram. Now we will look into the some terminologies used in the earthquake, and then how to locate the epicenter, how to measure the size of the earthquake. Focus. The point within the earth from which originates the first motion of an earthquake and its waves is called as a focus or hypocenter. The point on earth's surface directly above the focus of an earthquake is called as an epicenter. The distance between the epicenter and the place of interest is called as the epicentral distance. Now we have the SP time interval. We could be able to plot it in a graph and translate the time into the distance between the station that recorded the seismogram and the epicenter of the earthquake. First we will see on the travel time. For an example, how long does it take a P wave to travel 4000 km for a given epicenter distance? Go to the epicenter distance on the x-axis and go up to a correct curve. So here the curve is given as here P wave. So go up to the correct curve. Go over to the y-axis and determine the travel time. So here you could be able to see the travel time as 7 minutes. The second example, which is how to locate the epicenter distance. How far the S wave travel in 9 minutes. For that, go to the travel time on the y-axis and go over to the correct curve. Go down to the x-axis to determine the epicenter distance. Here you can see that 2600 km is the epicentral distance. Number 3. How you can arrive the time of an earthquake and given an epicenter distance and origin time. If an earthquake occurs at 2 hours 11 minutes 20 seconds, what time does the S wave arrive at a seismic station 9000 km away? Determine the travel time of the wave. Add travel time to the origin time given, which is 2 hours 11 minutes 20 seconds. Add with 22 minutes with 20 seconds. You could be able to get as 2 hours 33 minutes and 40 seconds. And number 4, how to see the origin time of an earthquake. Suppose for an example, if a P wave arrives at a station 8000 km away at 12 hours 15 minutes, then what time does the earthquake originate? So determine the travel time of the given wave. Subtract arrival time you were given minus the travel time. 12 hours 15 minutes minus 11 minutes 20 seconds. The answer will be 12 hours 3 minutes and 40 seconds. And fifth one, how to find the difference in arrival time between P and S waves. Suppose if we given an epicenter station which is 5000 km away, how long after the first P wave does the first S wave arrive? Line up a piece of scrap paper vertically on the epicenter distance given. Mark the locations where the P wave and S wave intersect your scrap paper. Line up the scrap paper on the y-axis with 1 point on the 0-minute mark. The second mark will indicate the difference in arrival time. So your answer is 6 minutes 40 seconds. Then, how to locate the epicentral distance? By triangulation method, you could be able to get the epicenter, that is, which is the locating the epicenter. We can find out the epicenter of the earthquake by looking at the seismograms from different recording stations. Signals arrive first at the closest station and last at the one furthest station. Time difference between the P and S waves tells us the distance of the earthquake from the seismograph. By measuring this at 3 stations, we can work out where the epicenter is. Intersection of the circles whose radius is equivalent to the distance from the earthquake gives the epicenter. Then finally, the topic is on measuring the size of earthquake. The height of the waves on a seismogram indicates the amount of ground motion. The ground motion can be used to calculate the magnitude, which is the measure of energy released by an earthquake. The larger the magnitude, the stronger the earthquake. The Richter scale measures the ground motion from an earthquake to find the earthquake's strength. It is a qualitative measure. An increase in the magnitude by 1 unit corresponds to a 10-fold increase in ground motion. Now we can see how to measure the size of an earthquake. So the picture shows the nomogram. To measure the distance between the first P wave and the first S wave. P wave is called as a primary wave, S wave is called as a secondary wave or second wave. Find the point for 24 seconds on a left side of the chart below and mark that point. According to the chart, this earthquake's epicenter was 215 kilometers away. Measure the amplitude of the strongest wave, which can be seen from the seismogram. On this seismogram, the amplitude is 23 millimeters. Find 23 millimeters on the right side of the chart and mark that point. So now place a ruler on the chart between the points you marked for the distance to the epicenter and the amplitude. The point where your ruler crosses the middle line on the chart marks the magnitude strength of the earthquake. This earthquake had a magnitude of 5. Earthquake strength is also measured by the moment magnitude scale, which is more accurate for large earthquakes than the Richter scale. Moment magnitude scale is widely used nowadays. This magnitude is based on seismic moment of the earthquake. MW is equal to mu into A naught D, where mu is the rigidity of the earth, which is multiplied by the average amount of slip on the fault, which is D, on the size of the area that slipped, which is A naught, which is a better measure for bigger earthquakes. The moment magnitude of an earthquake is expressed by a number. The larger the number, the stronger the earthquake. If you have a magnitude of 8 and higher, which is categorized under great earthquake. If you have a magnitude of 7 to 7.9, it is categorized as major earthquake. If a magnitude of 6 to 6.9, then it is classified as strong earthquake. So like that we could be able to see the magnitude in terms of number. The effect of an earthquake and how the earthquake is felt by people are known as the earthquake intensity. The modified Mercalli scale is used to describe an earthquake intensity. Intensity values are usually highest near the epicenter. It usually depends on local soil condition, type and quality of structures, epicentral distance, focal depth, and performance of earthquake resistant structure. So this is the modified earthquake scale. It ranges from 1 to 12 and it classified as insignificant, very light, moderate, slightly strong and catastrophic. It depends on local soil condition, type and quality of structures, epicentral distance, focal depth, and performance of earthquake resistant structure. So you can see here the modified Mercalli scale, which ranges from 1 to 12. It should be in the form of Roman number. So it is classified as from 1 to 12. In this lecture, so far we have seen how to locate the epicenter and how to measure the size of an earthquake. In the next lecture, we will be seeing on the seismic hazards, architectural aspects of the structure, and then the earthquake resistant design of various kinds of structures like masonry structures, steel structures, and RC structures. Thank you.